The first system that we will study as an example of the simple harmonic motion is the mass spring system. This system has a mass m, a spring and a support. The one end of the spring is attached with support, the other end is attached with the mass. The surface on which this mass is moving is frictionless. Right now this mass is at rest at the position O, so we can say that position O is the mean position. Now I apply a force F with my hand on the mass M and I displace it from point O to A. The displacement which is taken away from the mean position, you can see that this is X right now. It is natural, more force we will apply, more will be the displacement that will occur over here. So you can conclude that applied force is directly proportional to X. This is our Hooke's law as we know from our previous knowledge. As soon as I release my applied force at this point, a reaction will be generated in this mass spring system. Why? You know that common sense, whenever we stretch any spring or we compress any spring, because of elasticity it wants to come back to its original shape which was at the start. That force, which is the reaction force, will be in the opposite direction to the applied force. Now what will be the direction of the reaction force? It will be towards the mean position. This reaction force is known as restoring force. The restoring force tends to take the mass back to the mean point. So if applied force was directly proportional to X, so we can say that restoring force is directly proportional to minus X according to Hooke's law. This minus sign shows that the direction of this force is opposite to the applied force. If you change this proportionality into equality, it will become F is equal to minus Kx. F is equal to minus Kx, where K is the proportionality constant. The proportionality constant K is known as spring constant. It tells us that how hard or soft a spring is. If K is more, the spring is hard. It is tough to stretch or compress the spring. If K is less, it means that spring is soft. It can be easily stretched, it can be easily compressed. I am writing the Hooke's law here again because it was in the previous slide. I need it over here. Now, according to Newton's second law, whenever we apply a force, what the second law states? F is equal to ma. Now, this F and this F, they both mentions the same force, that is the restoring force. So I can compare 1 and 2. If I compare 1 and 2, it will become minus Kx is equal to ma. I change the places. I take ma on the left side and minus Kx onto the right side of the equation. It will not have any impact on the meaning of the equation or the value of the equation. It remains the same. Now take this m to the other side and write it in the denominator of k. Now if you look at this expression and if you look at the experiment or the system that we are studying, that is the mass spring system, throughout the experiment we are using the same spring, so k is a constant, and also throughout the experiment the same mass is used, so m is also a constant. So constant divided by constant gives you another constant. So instead of writing minus k by m, I will write minus constant into x. So acceleration is Now proportional to minus x. How I have done this? Previously what we were doing, we were converting proportionalities into equalities by introducing the constant. Now we will do the reverse. We will remove the constant. Then this equation will become a proportionality, that is a proportional to minus x. Now we will conclude by studying this proportionality, that is a proportional to minus x. Acceleration of this motion is important right now. You know that acceleration is a vector, so it will be having magnitude as well as direction. Now what you conclude from this proportionality, ignore the negative sign, a proportional to x, where x is the displacement from the mean position and how much the mass is away from O, and acceleration is the acceleration produced in the body, you know it very well. More the displacement, more the acceleration. Less the displacement, less the acceleration. So if the body is away from the mean position, acceleration will be more, but if the body is moving away from the mean position, the acceleration will increase, or if the body is moving towards the mean position and in this direction, the acceleration will be decreasing. So I can say that at mean position displacement is 0, so acceleration is also 0. At extreme position, displacement from the mean position is maximum, so acceleration is also maximum. Now let us discuss the direction of acceleration. Let us consider this minus sign. It says that a negative x. So it means actually or physically that acceleration will oppose the x, where x is the displacement from the mean position. Now there are two possibilities. Either the body is moving towards the right side of the mean position or towards the left side of the mean position. This is the second possibility. When it will be moving towards the right side, direction of displacement away from the mean position will be in this direction. Now where the acceleration will be opposite, so it will be in this direction, so acceleration is having a direction towards the mean position. Now let us consider the second possibility. If the mass is moving towards the left side of the mean position, now this will be the direction of displacement. If the acceleration will oppose it, it will be towards this direction, so you can see that acceleration is again towards the mean position. So direction of acceleration is all the time towards the mean position or the fixed position. I can conclude that the motion of a mass spring system is simple harmonic motion, as we have discussed the definition earlier.